Today we are going to investigate Lesson 4.7, Solve a quadratic by completing the square. Take a few minutes to look at the 4 warm-up problems. Factor each of those trinomials into a product of 2 binomials. Recall from Algebra 1, you're looking for factors of 4 that sum to 4. In number 2, factors of 9 that sum to 6, and so forth. Factors of 16 that sum to 8, and factors of 25 that sum to 10. You should notice something interesting about your answers. As you factor each of these trinomials into a product of 2 binomials, you should see that the answer is the original binomial times itself. The 4 original trinomials are what we call perfect square trinomials, meaning when you factor them, they're equal to a binomial squared. If we generalized it, each equation that was given to you in the warm-up is in the format x squared plus bx plus c. I've taken each of the original 4 equations and simply written the 4 in the B column and the second 4, which is in the C column. Equation 2, B was 6, C was 9. Number 3, B was 8, C was 16, and so forth. I want you to play around with these numbers and see if you can establish a relationship between B and C. More specifically, what do you do to 4 to get 4? What do you do to 6 to get 9? What do you do to 8 to get 16? And 10 to get 25? The pattern that is being established is that in order to calculate C, you take B divided by 2 and then you square it. B divided by 2, I'll put that in parentheses, and then you square that difference. Let's take a look. B divided by 2, the quantity squared, is what will now be in the place where C was originally. That format creates a perfect square trinomial. Again, a perfect square trinomial is a trinomial that, when factored, is written as the product of a binomial times itself. What if you don't have a perfect square trinomial given to you, like the 4 in your warm-up problems? You will have to create one. For example, if I want to force a perfect square trinomial, I need to come up with the number to fill in place of the green box, so that if I factor that trinomial, it would be a binomial squared. How do we figure out what goes in the box? Remember with the pattern we just established. What is C going to be? B divided by 2, the quantity squared. So we have to take 16 divided by 2, get 8, and then square that, which is 64. So the number that I need to force a perfect square trinomial is 64. Notice when I factor that trinomial, it's x plus 8, the quantity squared. X plus 8 times x plus 8, if you use FOIL, would take you back to the x squared plus 16x plus 64. Let's take a look at another one. What number should be filled in place of C? The pattern we established, B divided by 2, the quantity squared. And in this case, B is negative 26. Negative 26 divided by 2 is negative 13. Square that, and you'll get 169. That's the number to substitute in place of C. We've now forced a perfect square trinomial. I could then factor this perfect square trinomial, and again, hopefully the pattern that we see So when it's factored, it's x plus negative 13, the quantity squared. You can actually work out factoring, looking at factors of 169 and finding the pair that summed to negative 26. But hopefully you've recognized the pattern. The number that goes inside of the binomial is simply the b divided by 2. Negative 13 is what would be filled in that place. Notice that any time you have a perfect square trinomial, you can solve the equation in very few steps. We're going to factor the left side of this equation because as we double check, where'd the 100 come from? 20 divided by 2 squared. 20 divided by 2 is 10, and 10 squared is 100. So we can factor the left side of this trinomial into an x plus 10, the quantity squared. And we can factor the right side. 81 is 9 squared. If we're going to solve this for x, and x is inside of parentheses, it's being squared, we will need to square root the left side and square root the right side. Remember squaring and square rooting? They cancel out each other. So the left side becomes an x plus 10, and the right side becomes plus or minus 9. Remember, the squaring is our hint that we're looking for at most 2 answers. In one situation, the x plus 10 could equal positive 9, and in the other situation, the x plus 10 could equal negative 9. Subtract 10 from each of these equations, and we have our 2 answers. If I put negative 1 back in place of x in the original problem, the left side indeed will equal 81. If I put negative 19 in place of x in both places in the original equation, that left side will equal 81. That's the benefit of seeing a perfect square trinomial. You can factor it, then square root it, to eventually solve for the 2 numbers to substitute in place of x that will make the left side of the equation equal the right side of the equation. We can continue using this idea to solve other equations. But let's stop with this lesson for today, and we can complete these problems tomorrow. The problems that I'm assigning for you for today is question 1 through 15 on worksheet 4.7.